which is an effort to kind of decentralize Bitcoin mining so that we don't run into problems which P2P pool ran into, which is essentially the scaling issue. That's why decentralized mining at scale. But why do we want scale? Why do we want to decentralize mining? I'm going to get into it one by one. By the way, I'm Kulpreet, and we are in September 2022. So summary, if you want to take away one thing from this talk is that Bitcoin mining can be decentralized. We strongly believe that. I think there are only technical challenges. There is no theoretical impossibilities as far as we can see, right? So that's why it's kind of nice, interesting area to work in so that you actually can push things forward, I believe, and that's where we are. So the structure is essentially, I'm going to talk about why mining centralization is a problem, right? I think a lot of people understand that, but I'm just going to quickly go over that. And why decentralized mining needs to scale, right? Then I'm going to talk about a proposal we shared a few months ago on the Bitcoin Dev mailing list, and then talk about some of the problems we found with that and how we're trying to solve those. So that's kind of the structure that we're going to go through. So mining centralization is a problem. So first and foremost, right, if you can have centralized mining, you might as well have staked Ethereum or something. So that's the point. Like if you actually depend on a few rich people to kind of mine things for you, you're not kind of really doing what Bitcoin wanted to do. So it goes against the ethos of Bitcoin mining. So that's kind of the big strong motivation. The other one is that centralized pools can be forced to censor transactions, and we've seen that recently happening in a few places. So that is something we want to kind of let miners, hopefully anonymous miners, be able to build their own blocks, include the transactions that they want to include in it, and mine them, right? And then share the results with the network. So can we do that? I think we can, and we're going to talk about how we do that. The other big problem is that the pool operators are keeping accounting opaque, largely. I think only one pool, I think essentially /pool, lets you kind of verify the hash rates, etc. But still the accounting is opaque. You send them shares, and you just hope that they give you your rewards as they should have, right? You just trust them. But that's one thing. The other problem is that if you can actually have accounting available on a peer-to-peer network, on a decentralized network, which is publicly verifiable, publicly usable, then you can build other interesting stuff on top of it. For example, one of the big motivations of Braidpool is to be able to allow some hash rate derivatives so that if, as a miner, I can hedge against difficulty. But we're not going to go into the details here because I just want to keep this very simple and clean. So this is another problem that, accounting is opaque. We really should hope that we can make accounting more transparent. I think maybe pool operators will want to do that eventually, or should. So why does decentralized mining need to scale? The issue is you could have P2P pool run it with your 5 friends, and you have decentralized mining, but your variance would be very high. You probably won't find a block for a while, right? Depending on your hash rate, but so you won't have any payouts. You can't do stuff with it. So, but why couldn't P2P pool scale? As my understanding is, there were 2 big issues with it. One was there was a linear chain of shares. So if shares arrived late, you couldn't put them into the accounting so that you couldn't reward them nicely. So that was a problem with the dead on arrival shares, /Orphan shares, etc. So that was one issue. The other issue was that payouts were in the Coinbase. And as historically, the Coinbase size got limited, we couldn't put too much payouts into it. So you had a cap on how many miners could actually be paid out using the Coinbase. So that was a big issue. And we need to solve that issue if we want to make P2P scale, P2P pool scale. So that was why we want to decentralize mining at scale, right? I mean, of course, the point is also the variance. If you have a bigger pool, then you have a lower variance. So we really need to be able to accommodate 10,000 miners. That is my personal goal, I believe, but we're working towards it. So now I'm going to quickly go over the proposal that we shared, and then going to talk about the problems with that proposal. Okay, so where did the proposal come from? Essentially, I have two guys to blame here, Bob McElrath and Chris Belcher, essentially. So Bob gave a talk about Braidpool, that's where the name comes from, and how we can decentralize mining and build hash rate derivatives on it. And I just saw it on YouTube, and I was like, this looks like an interesting problem, because my background is in a bit of distributed systems. I was like, okay, this looks like a fun, interesting thing to work on. And another problem was he used a DAG of messages which is what I had used during some of my past careers. I was like, I know this stuff. Maybe I'll be able to do something here. So that was one thing. Then I kind of pinged him, and I ended up on IRC, and I saw Chris Belcher had written something about it on Bitcoin Talk. And that was very interesting because he was solving the problem of the payouts in the Coinbase by using payment channels, right? And that was kind of a bit of a mind-bending thing to read about how he approached that problem. But now I think I have a fair understanding of how that works and how we can use it. So what do we want to do, right? So the two problems that we wanted to solve was to get rid of a linear chain. So what we say is, look, we'll build a DAG, and that's it. All problems in computer science can be solved by a DAG. Let me just introduce a new quote here. So if you see the DAG here on the side of the screen, there are L and R are the left and right, we call them. They are the Bitcoin blocks that have been found. And in the middle, the A's and the B's and the C's are the shares being created by the ABC miners, right? And there's only one rule, that any miner that puts out a share includes references to all the shares by all the other miners, last share by all the other miners that they've seen. Now this DAG can be simplified and optimized, but for the moment, for elucidating what we're doing here, the Bitcoin node includes the last B2A3C3 shares that it saw. So, and because eventually a Bitcoin block will appear, hopefully, the DAG becomes eventually consistent, right? So all nodes will see the same DAG, as long as they can request other nodes for any missing information, just like we do in Bitcoin. So this kind of eliminates the dead on arrival and orphan shares, and they can be fully accounted for. And now how we give the payouts is a secondary question. At least we have the information, right? So, I mean, there's some debate about, do we do PPLNS or PPS, and both are possible because you have the information. And the best key thing is that all the miners can verify that they are getting paid according to the shares that they generated. So that's I think is cool. And it provides transparent accounting is what I'm saying there. So, and then the second thing that we use to eliminate the problem of all the payouts being in the Coinbase is that we use payment channels. This is exactly as Belcher specified it. There's some tweaks now, but it's more or less the same way. So we can make use of scalable blockchain in a scalable way, but there is a downside, which is what we did in our proposal, which was that we just use a single hub. And our idea was, look, we can hide the hub behind a Tor hidden service or something, and I think that was a flaw. So with a single hub-based channel, which is doing the payment channels for all the miners, I'll get into the details of what this all means. We just depend on a single hub, which is pretty shit. Okay, so before I get into some more details of how the interaction happens, I'm gonna go quickly over how the channels transactions are structured. So this is the single hub solution that we shared on the mailing list. And it's a simple solution, right? What goes into the Coinbase is that both the H is the hub and M is the miner. They both sign the transaction, and they can both the transaction can be spent and sent to the hub. The money can be spent to the hub. But what if the miner is not available? Then we use the second branch, which is where the hub can reveal a secret and then sign it and then be done with it. So the hub just generates a secret and keep it secret for himself, right? So that's one thing. That is only the case where hub unilaterally spends, right? And the last case is if the hub goes away or disappears, the miner can take the money in 6 months, right? Not all the miners, but just this miner, the one who found the Bitcoin block, the one who generated this Coinbase. So each block would have a Coinbase that looks something like this, okay? So, and then what is the payment channel transaction is something like this. There's a funding transaction, which is the 2 of 2 of the hub and the miner, and then which has been funded by the hub with the money 0 going to miner and whatever going to the hub. But then in the case that a miner finds a block, we'll talk about how this happens, but there is a cooperative commitment, which is the update to the channel. What happens is the hub gets the funding minus payout, and the miner gets the payout. So this is the cooperative commitment spent where both the hub and the miners sign the transaction. But in the case where the miner is not signing, the hub spends the transaction unilaterally, which was the second branch here, the hash h plus blah, blah, blah. In that case, the miner can take the hash and still spend this channel, which will essentially close the channel, and the miner will get the money. And all the miners can do this, because as soon as the hub spends the branch revealing X, all the miners will go, okay, look, I'm going to take the money and go. This is the end of Braidpool, unfortunately, or that round of Braidpool. So at least the hub can't steal the money. That's the whole point. So this is how it was structured. The way that the message passing happens is the hub opens one-way channels to all the miners, right, which is pretty straightforward. Miner 2 finds a block. The hub notices it on the Bitcoin node because he knows what the Coinbase looks like, then sends updates or the commitment transactions, as I said, to all the miners. The commitment transaction sent here is the one which is the cooperative commitment, which is basically, no, sorry, where is it gone? Yeah, no, that's in 3. So the update is essentially the cooperative commitment, but it's not signed yet. So once the hub sends all the commitment transactions to all the miners, and remember it's happening on the peer-to-peer broadcast network, then miner 2 sees that all of these transactions have been sent to all the other miners, and then they go, okay, yeah, hey, miner 2 says to hub, look, I'm happy to sign that commitment transaction, so you, the Coinbase, so you get all the money. So hub gets all the money, which he's already sent out all to the rest of the miners. So there is some kind of interaction happening between the hub and the miner. The hub has funded the channel, the hub channels, sorry, and then the hub sends the money over the channels to the miners, and then one of the miners, the one who found the block, releases that money for the hub. So this is the good case situation. But however, as you all notice, this is one single centralized hub is pretty shit. So single hub is not a good idea. That's the problem is number one with the proposal that we shared. So can we use multiple hubs? It becomes the question, right? In fact, Belcher did think about this problem, and he thought about using Taproot and Mast to solve that problem. But we'll talk about another solution that we think is maybe slightly better. So the Taproot Mast solution that Belcher proposed was something like this. Now, there's some errors in this slide, and I apologize for that. At least I got the presentation in time here. So SH and SM should all be M, essentially. But what's happening here is, suppose there are 2 hubs, right? What you can do is you can construct a complicated transaction in which if this party is not there, then use that branch. If that party is not there, then use that branch. And this becomes, like, this explodes in complexity. It's basically combinatorial, right? So if you have 10 hubs, you'll have as many number of branches. So there is a problem here, and then the solution was, we'll just mast it all up and put it into Taproot so it doesn't take too much block space. However, the problem is that if in the worst case you need to reveal a long branch along the mast, then you need to reveal a lot of signatures. And that's kind of taking up a lot of block space and puts a cap on how many hubs can be in the transaction. The other thing that I found very annoying thought was a problem was all these time delays that you need for CSV 2 weeks, CSV 3 weeks, CSV 4 weeks. If you have 20 hubs, you're like waiting for a half a year or something. And the other qualm is that the punishment-based schemes can result in some games. So as we see this debate around L2 and Lightning's become punishment-based schemes. So can we do something else? Can we do something better? So just to reiterate, the current proposal had problems that Taproot-based multiple hubs don't scale, right? Payouts to miners require signatures from all the hubs, which is kind of sucky in the cooperative case. And if a single hub is unreachable, then you just end up closing channels and you have to set them all up again, which is kind of sucky too. So there's a few things that don't work nicely here. So, but the good things about multiple hubs is that you remove the centralized hub, plus you also reduce the liquidity requirements. What that means is, so if a hub opens channels to say 100 miners, and they want the channel to be staying around for 6 months, you need to be able to put that much money up front, right? Which requires a lot of liquidity from a single hub. Can we kind of remove this? Can we kind of reduce this problem, make it simpler? So the solutions we're working on, essentially, use threshold signatures. So just a quick aside on what threshold signatures are doing, right? So they basically say N parties can generate a public key, and T+1 parties can generate a valid signature for it, right? But T parties can't, only T+1 can. So you may require T+1, which is like threshold, right? And no single party ever sees a the private key, which is kind of cool. You can do some interesting stuff now. So this has recently been possible because Schnorr has made it into Bitcoin, and we can do threshold signatures now, which also happen not on chain. They happen offline and all that stuff. So it's all good stuff around it. So how would we use that? But before we go into how we use that, there are some problems with threshold signatures, right? Which is that the communication complexity is big O n cube, which is like in the naive implementations, right? In the simple implementation, I shouldn't call them naive actually, but from a communication perspective, they seem pretty simplistic. So what some protocols do is they trade off robustness for the size of T and the communication complexity. Sorry. So can we do better than the master construction is the question, right? So one of the ideas is that use threshold signature between all the miners. So if you have 10,000 miners, 1,000 miners, let's do a threshold signature. Now, that's a cool idea, but there is a big problem with that because of the big O n cube. The good thing is that we don't have a single hub. But can we do something here? We don't know. This is an open question, and Bob is spending a lot of time looking into this, and I'm trying to just keep pace with understanding what he's saying. So can we make use of P2P broadcast network model, right, which is what we have available, and this other requirement that we probably need to sign a transaction either every 10 minutes, which is something that I've not talked about, or in the channel case, once every 2 weeks or once every month or something like that. So can we kind of build something by piggybacking messages required to build these threshold signatures on top of our shares that the miners are sending out every second or every 2 seconds or whatever frequency they want to send them at? So this is an open question, but I really like this idea as long as we can solve this problem right. There are some optimizations that people have worked on in the Definity space, and Roast is also another implementation that, or another proposal that kind of tries to scale things up. The other idea is let's not do a threshold signature between all the miners, but just between the hubs, right? So again, we have no dependence on a single hub. There's a simple Coinbase, so that it's very similar to the original proposal. We don't have that masked big tree of combinatorial branches, but just a very simple Coinbase where H is replaced by the threshold signature of the hubs. And whatever optimizations we do for 1,000 parties, we probably do, they'll probably stand for 100 parties too. So can we scale the hub to 100 parties? That'll be kind of cool. What we're trying to do here is get to a point where people can just participate in an auction in a way that they become one of the hubs, right? So that they actually get some, they can earn some money by providing funding to Braidpool, right? So this is a simple Coinbase transaction where H is replaced with the threshold signature of H. So it's actually brilliant that the Coinbase remains so simple. I like that. So this is what I was saying earlier, that if we have threshold signatures scalable enough for 100 parties, which I know a few people in the community are trying to work towards, so we'll just adopt what innovation they do. We can do an auction scheme similar to LN Pool. I don't know if people are familiar with it. I was thinking I could spend some time on that, but I don't know if I had enough time. What it essentially does is there's a blind auction between between Lightning channel providers who have liquidity to sell, and there's an auction round, and then voila, people have channels available to them based on what are the commissions that people want to use. So we could use similar constructs to kind of do funding for Braidpool, because essentially that's also channels, right? But the questions remain, like if we're just doing funding, threshold signature between hubs, what are the attacks here? And can we resist those attacks? It's something that we need to kind of think about collectively and maybe see if we can imagine all the scenarios, which we probably won't be able to, but still, we can try our best. So is this something we can do, or should there be a mixture between hubs and miners? But essentially, coming back to this, right, these are kind of technical challenges and some more game theory work that we need to do, but I don't see a computer science theoretical problem here that stops us from building Braidpool, is what my thing is, what my take is. So what are we doing now and where we need help? So we're kind of spending time in stuff that that is well understood, which is peer-to-peer communication, the DAG, the payment channels, and computing payouts from the DAG. So we're doing this, some other stuff there. This is kind of heavy engineering lifting, that's all. But then optimize and implement TSS for our network model, for our kind of peer-to-peer network model, broadcast-based network model. So that's kind of the open question, but that's how that work is continuing on the side. So that's it. So in conclusion, we believe decentralizing mining is possible at scale. There are some technical challenges, but I don't see any theoretical impossibilities here. So there are some links. I could have done a better job at the links, but this is all it is.
Maybe we have time for one question. There? Okay. I'm coming.
I should have not discovered the slides.
Hi, sorry. I was wondering if you could contrast it a bit with Stratum V2.
Sure. What Stratum V2 is trying to do is one thing which we want to use as well, which we will want to use in Braidpool, which is that secure the communication between the pool and the miners, right? That is a win. We just want, everybody wants it. The other thing about negotiating with the pool, the proposal for what transactions to include, we don't have that here. So in Stratum V2, the miners say, oh, I want to build a block like this, then send it to the pool, and pool says, yeah, go ahead, right? We say, pool, fuck off out of here, right? Sorry for my French. But I just build a block, and I start mining on it. I've got no one to say yes or no, right? So that's the difference. But the securing of the communication between the pool and the pool node, which the Braidpool node will be, and the miner, that we definitely want to use.
Okay, thank you, Kulpreet. So now, second panel of the day, big names. I want to invite Aaron, that will be moderating, and also Martin, Peter, Jimmy, and Lisa.
Hello.